Hey guys, how are you doing? Welcome back to my video series on solving LeetCode problems. I just finished solving the, this is the, I even forgot the title, the free sum. And I reached 98% in runtime. Memory not so good, but I'll explain to you how I did it. So what's the exercise about? Given an integer array nums, return all the triplets nums of I, nums of j, nums of k, such that I is different than j and it's also different than k. So I, j, and k are all different. The solution must not contain duplicate triplets. So yeah, each triplet is different. So let's look at this. Minus 1, 0, 1, 2, minus 1, 4. We need to find groups of 3 that the sum is equal to 0. That is like minus 1, and 2. All of them together is 0. Minus 1, 0, and 1. Also 0. So how do we solve this? So let me open a new JS Paint. So how do we solve it? So pretty much what we need to do is we need to create like hash tables of these values and iterate over them. So let me just copy this. And let me change the font size to 40. Okay, so now let's just do the unique values. Unique values are minus 1, 0, 1, 2, and also minus 4. So unique values. Now let's split them from the negatives and the positives. And also 0. So what I'm going to do now is I'm going to use a counter that will tell me, counter is like a hash map, which is the keys are the integers and not necessarily integers, but in this case we're counting integers, and the value is an integer that says how many times that value exists. So what we do now is minus 4 equals 1, minus 1 equals 1, 0 equals 0. Actually, let's have a counter just for the negatives and a counter just for the positives. 1 equals 1, 2 equals 1. This would be different if we had, let's say, a 2 here, like another value, 2, something like this. Then 2 would be 2. So what do we do now? Basically what we do here is, first of all, let's check. Do we have a 0? Yes, we have a 0. Actually, let's check if we have 3 zeros. If we have 3 zeros, the final result would be a list that would have the pair 0, 0, 0. In this case, it's not. Just have 1, 0. But if we have 1, 0 at least, we can check. Okay, so let's go through all of our negatives. Okay, minus 4. That's our negative. And actually, let's go through this list. Minus 4. Do we have any value from the positives that is equal to plus 4? So it will be minus 4, 0, and 4. No, we don't. But we have minus 1, 0, and 1. Okay, cool. So we add that, and we have that solution. Cool. So we just check if the negatives have the complements in positives. And that's the same as checking if positives have complements in negatives. Because, yeah, we don't have a minus 2. So now we go for each of the negatives. Let's go through each of the positives. And let's check if there are any pairs that could do that, which the sum would be equal to 0. So 4 and 1 plus 2 is 3. No, it's not 0. Then let's check if for one of the positives we have a count. One of the positives that the counter is more than 1, which is in this case this one, if this one plus 2 equals this one. In the case it does, so we can say we have the pair minus 4, 2, 2. Cool. Then we just put it here. Okay, let's go for minus 1. And yeah, minus 1. We can't really do anything with it. Oh, wait, I've missed something. We have 2 minus 1s. Sorry. So this is minus 1 again here. And I missed the minus 1 here. Minus 1, 0, 1, 2, 2. Yeah. This is it. So we have 2 minus 1s. So let's check if we have... first of all, let's check if minus 1 is even. And then we can... If then we can divide by 2 and find that one in the positives. We can't. Okay, let's do the same for the positives that we just did for the negatives. 1, let's find if all the pairs here sum to be 1. Oh, 4 plus minus 4 plus minus 1 is minus 5, so not the case. Minus 2, same 2. Yeah, minus 5 plus 2 is minus 3. Okay, now we check for minus 1. Actually check minus 2 and we try to divide it by 2. It's even, the result is 1. Let's check if we have minus 1 more than once. We do. Okay, cool. So that means we can also add 2 minus 1 minus 1. And these are the pairs that we can do. Let me see if we can do anything else. Yeah, no, this is it. And this is the final result. So let's get to implementing. So I have everything here. I'm going to comment something out because I don't want to repeat the logic. You'll get what I'm saying. So first of all, we do the counters. So we have my positive counter equals counter. Counter, I'm by the way importing from collections. Counter of x for x in nums if x bigger than 0. And then we do my negative counter, which is the same thing but smaller than 0. Then count of zeros, we check how many zeros we have. Then final pairs is going to be final result, as I said here. So let's just check the unique numbers. This is going to be helpful. I was getting some strange... Actually, let me delete this. So, first of all, let's check if we have 3 zeros, we add the 3 zeros to the result. So it's basically just moving this up. If count of zeros bigger or equal than 3, we append 3 zeros. So let's go. If we have at least 1 0, we can do that thing where we go through the negatives and check if we have the corresponding positive. That's where we did minus 1 0 1. So let me just do that same thing. For a negative in my negative counter dot keys, if minus 1 times negative, so it's the positive, or we can just go for absolute value of negative in my positive counter. We just do final pairs dot append, and then we add negative, 0, and absolute negative. So let me just run this. We have actually a different example here, but the result right now is minus 101, minus 404, minus 2, 3. Well, we have a lot here. So you have 3, minus 4, 4, 2, minus 2, minus 1, and 1, and we have 2 zeros. We don't have 3 zeros though. So, and now what do we do? Remember we check if we have, now we're going for each negative number, and then we check if the half of it positive is present. So we just do that. So for negative number, I'm going to delete this part. If negative number divided by 2, rest of the division by 2 is equal to 0, then let's check if negative divided by 2, the absolute of negative number divided by 2 in, actually we don't even need to do this. I think we can just go and do my positive counter of absolute negative divided by 2 is bigger than 1, then yes, we can say final pairs dot append negative number and this twice. And now we do that thing where we check for all of the pairs of negative numbers. So for next negative number in list of this negative index plus, so if the absolute of this is in my positive counter, so negative plus the next negative number, so these are for each pairs. Final pair append minus, can go absolute here. Oh, my negative unique numbers. Oh yeah, I need to replace this. My negative counter dot keys. Yep. So this is the logic that we do. Let me just print this out. What we have so far. So the final pairs we have ones that have zeros and just one positive and two negative. And now I'm going to comment out the code that does pretty much the same thing as previously, but for two negatives and one positive and two negatives. So this is going to be my positive counter.keys, and this is going to be list of my positive counter.keys. And let's run this again. And now final pairs. We have one positive, two negative, one positive, two negative, one negative, two positive. So yeah, let's submit this. So fingers crossed. List append takes exactly one argument. Where did this happen? Line 21. Oh, I didn't create the array. Let's see if this works now. Okay, it worked, and it actually, no, it didn't do better, but it should have done better actually. Well, it's doing a little better. Yeah, hope you guys enjoyed it. See you later.